Now let's do an example of a weak acid titrated by a strong base. So, and let's calculate the pH before the equivalence point. So this one is calculate the pH of the solution formed when 45 mL of 0.100 molar of sodium hydroxide is added to 50 mL of 0.100 molar of acetic acid. This is basically what we have is like here we have, let me see if I can, no, right here. Here we have a beaker, and in this beaker we have the solution of the acetic acid, HAC. We have there 50 mL of that solution of acetic acid, that is 0.100 molar. And with the burette here, we have a solution of sodium hydroxide, and we are adding to the solution of the acetic acid 45 mL. So at the end, we're going to have basically 50. This was 50 here. 50 plus 45. So it's going to be basically 95 mL. That would be the total volume once we add both of them. Okay, so basically this is what is happening here. We have the acetic acid solution, 50 mL of that, and we are doing the titration with the sodium hydroxide. So let's identify here. Here we have a strong base, and here we have the weak acid. Okay, weak acid is the acid, acetic acid, and the strong base is the sodium hydroxide. So we need to calculate first the moles of each of them. So let's calculate the moles of the acetate, the acetic acid. Moles of acetic acid is going to be equal to the volume that we add, or we have, that is 0.05 liters. We change from milliliters to liters, times the concentration of the acetic acid, that is moles of acetic acid, divided by the volume, that is 1 liter. This is the molarity. We can cancel the units of liters, and we're going to have 5.0 times 10 power of minus 3 moles of the acetic acid. Now we calculate the moles of the sodium hydroxide. Sodium hydroxide is a strong base, so it's dissociated. The concentration of the ions are going to be equal to the concentration of the compound. So here we have 0.045 liters of solution, and we multiply by the concentration of sodium hydroxide divided by 1 liter of solution. And now we can cancel the units of liters, and we have the moles. So this will be equal to 4.5 times 10 minus 3 moles of OH. Now, let's remember that we have acetic acid. The acetic acid is reacting with OH, and this will produce acetate, negative here, plus water. So this is the reaction that the neutralization reaction that has been done here by adding this sodium hydroxide to the acetic acid. We have acetic acid plus OH producing acetate plus water. So we need to determine each moles of them, okay, before and after the reaction. So before the reaction, how many moles of the acetic acid we have? We have 5.0 times 10 minus 3. Of OH, we have 4.5 times 10 power of minus 3. From the acetate, we don't have, and water is constant. Now, let's talk about the change. In the change, we need to look for the limiting reactant. So which of them is the lowest that we have? In this case is the hydroxide. Okay, so the change is going to be all the moles of the hydroxide that has been consumed. So it will be minus 4.5 times 10 power of minus 3. And for the acetic acid also, it's going to be the same amount of moles, minus 3. And because we are consuming the acetic acid, we are producing acetate. So now it's going to be plus 4.5 10 times 10 power of minus 3. So after the reaction, we're going to have from the acetic acid 0.50 times 10 power of minus 3. From the OH, we're going to have 0. And from the acetate, we're going to have 4.5 times 10 power of minus 3. So now let's calculate the concentration after the reaction of each of them. So let's start, for example, for the concentration of the acetic acid is going to be equal to 0.5 times 10 minus 3 moles divided by now the total volume, that is 0.095. Remember, that is, we need to add both volumes, the volumes of the acetic acid that was 50, plus the one of some hydroxide that was 45. So that's why it's 0.095, and this is liters. Okay, so this is going to be equal to 0.0053 molar. Let me rewrite these two numbers again. 53. There you go. And the concentration for the acetate is going to be equal to 4.5 times 10 power of minus 3 moles of the acetate divided by the total volume, 95. And this is going to be equal to 0.0474 molar. So, one way to determine the pH is using the Ka, because for this one we know that Ka, remember that if we have the acetate as we did before, let's write this, the acetic acid is going to be in equilibrium with the acetate, that in this case is plus H positive. Okay, so that means that the Ka for this equilibrium is going to be equal to the concentration of acetate times the concentration of H positive divided by the concentration of the acetic acid. And the Ka for the acetic acid is equal to 1.8 times 10 power of minus 5. So for this equation, we have the value of the concentration of acetate and the concentration of the acetic acid, and also the value of Ka, so we can determine the concentration of OH, of proton, of H positive. And with that value, we can calculate then the pH. So we need to substitute the values. Let's move this a little bit down here. So we can rearrange this equation, and we can say that the concentration, let me use the other color. The concentration of H positive is going to be equal to Ka times the concentration of acetic acid divided by the concentration of acetate. So this is going to be equal, there's an equal symbol, this is going to be equal to 1.8 times 10 power of minus 5, multiply that by the concentration of the acetic acid, that is 0.0053, and this will be divided by 0.0474, that is the concentration of the acetate. And the concentration of H positive is going to be equal to 2.0 times 10 power of minus 6 molar. So the pH is going to be equal to minus log the concentration of 2.0 times 10 of minus 6 molar. So this is one way to determine the pH. This will be equal to 5.70. This is the pH before the equivalence point for this combination of the sodium hydroxide and acetic acid. Also, we can determine this by using the Henderson-Hasselbalch equation. You can practice that. For that, you need just the pKa. You have the Ka here, so you can determine the pKa by this value. And you have the concentration of the acetic acid and the acetate. So just substitute those values in that equation, and you can determine the pH also using that equation.